My name is Alexandru Jecan. I am a Java consultant and author. And back in 2014, I founded a small consulting company in Munich called Rodetech GmbH. And today I'm here in order to talk to you about Project Jigsaw in Java 9. Most of you already know what Project Jigsaw is. It's the new platform system introduced, the new modular platform system introduced in Java 9. It has been working, Oracle worked for almost 8 years at Project Jigsaw. It started back in 2008, and between 2011 and 2014 there has been an exploratory phase, and now here we are in 2016. Java 9 will be launched in July 2017. There has been a 4-month delay. It should had been launched in March, but due to many design issues and many stuff, it has been again postponed. First 6 months, now another 4 months. I would like to set a little bit the expectations in this talk. This is an introduction to Project Jigsaw, so I won't be able to touch some advanced topics and stuff. I will just be able to scratch the surface in 35 minutes, and I will. So we will see what plagued Java developers over the last several years. We will talk about modularity and present some general aspects on it. Then we will see how the JDK has been modularized, and we will show the new module graph that we have now, but we will see only the Java SE modules. The source code of the JDK has also been modularized, and we have a new structure of the JDK and JRE. The internal APIs have been encapsulated, and then we will show you how you can define a Jigsaw module, what kind of modules do you have in Jigsaw, and we will talk about the accessibility changes in Java 9, because the accessibility has been modified completely. We will see what implied readability is, we will see what a modular jar is, and what JMod files are. We will see how we can package package code, and then we will see the newly module path that has been introduced in order to replace the class path. Then we will compile and run using JDK 9. We will show you the JLink tool, which is used in order to build a smaller runtime image, so in order not to have all the modules. And we will see the enhanced Jade App Store that can search of JDK internal APIs and show what kind of dependencies do you have in your code. Then we will just scratch the surface how you can migrate an application to Java 9. There are two possibilities, top-down migration and bottom-up migration. And then I will give some advice of how you can prepare for Jigsaw, what you should do in order that your code won't break. And let's start. Let's see what actually plagued Java developers over the last several years. There are many things, but two things are very important. First is the big, indivisible, and monolithic JDK, and then is the class path. Regarding JDK, you know, it is very hard to install it on small devices, and it has a low level of maintainability because there are lots of dependencies between classes. And if you want to change something, then you have to go in other places in your source code and also make a lot of changes. The JDK now has about 60 megabytes, and you can't split it because you have a lot of dependencies, and it's difficult for small devices, for embedded devices, to make it to install it and to make it work due to its complexity. You have there a lot of stuff, legacy stuff that you actually don't need or need a little bit, like Corba and so on. So splitting the JDK into modules is one of the most important things and is the purpose of the JDK modularization with Jigsaw. Then we have the Classpath, and we know we have a lot of problems regarding Classpath. Classpath, you put everything, basically you put everything on the Classpath, and you can't say if something is missing or not. Then you can have conflicts between different versions of jars. There are popular frameworks that have hundreds of jar files on the Classpath, and when a jar is missing, the JVM breaks the execution at runtime. So you can't know if something is missing. The application works, and then maybe you will get class not found exception. And with Jigsaw, this doesn't happen because you can't start the application. It won't compile anymore. Then it's difficult to, using Classpath, you have to load all the classes from the Classpath. But, and if you want to search for a class, and this is a cost on performance, but using Jigsaw, you can, you know exactly where the class is, and it's a great performance improvement. And on the Classpath, the dependencies between jar files are not fulfilled, which is also bad. Then I will start with a little bit of theory, general aspects on modularity. So advantages and properties of modularity. Some of them are maintainability, reusability, high module cohesion, and low module coupling. And I want to talk a little bit about them, very general. Basically, maintainability, it refers to the degree to which a software system is being upgraded, basically, after release. And you know, a big monolithic software application is difficult to maintain if it has many dependencies inside of its code. And maintainability is ensured by simplicity. How can you improve maintainability? If you provide an interface and not direct a reference to a class. Also, duplicating code decreases the level of maintainability because you have to change code in many places, and the higher the degree of maintainability, the higher the quality of software. Then you have reusability. This is the degree to which we can reuse or replace a module. It avoids duplicating code and reduces the number of lines of code, and so improves quality of software. It speeds the software development process and increases productivity. So basically, modules can be reused because they implement a well-defined interface. Reusability is also increased by reducing the dependencies between modules. And for instance, when you migrate applications, reusability is very important because migration becomes simpler by being able to reuse software components or modules. Then you have high module cohesion and low module coupling, and this is what you basically want to achieve in context of modularity. Cohesion measures how the elements of a module are residing together, and it can be achieved by reducing the complexity of the module, by reducing the complexity of the method, of the methods described in the module, and by defining only one predefined scope for the module. Then you have low module coupling. Coupling specifies the level of interdependencies between modules. Basically, the interfaces have to hide their implementation, and the resulting modules are independent and can be modified or swapped without fearing or breaking other modules or the application. Introduction to Project Jigsaw. What is Project Jigsaw? As I told you, is the new modular system introduced in Java 9. Which are its goals? There are many goals. It's to provide a flexible platform, is to improve performance, is to make it easy to develop Java applications and also to improve security, which is an important topic in Java. So these are some of the goals of Project Jigsaw. You have a lot of documentation on the internet, the Jigsaw official OpenJDK website where you find lots of stuff. Then you have the specification document, everything that has been implemented. You have, I selected 3 mailing lists. There are a lot of mailing lists, but Jigsaw development mailing list is very active. There are lots of discussions there, lots of open issues that are discussed, and lots of proposal enhancements. And if you have any proposals to enhance Jigsaw, you can post there your proposals. Then we have the new API for Java 9 Standard Edition. And we also have the issue summary, because there are definitely open issues and open questions, and you can also check them. Here is the link to download the JDK 9 with Project Jigsaw. Project Jigsaw has been merged into Java 9 at the beginning of this year. So if you download JDK 9, you already have Project Jigsaw included. Now, what are the most important characteristics of Project Jigsaw? It's strong encapsulation, reliable configuration, security, scalability, and performance. So strong encapsulation. It allows a component to declare which of its public types are accessible outside of the module and which are not. And it basically hides modules internals. It hides the inner implementation. And it is achieved in Java 9 using modules. And it's very important, strong encapsulation also makes in Java 9 a reflective access impossible. So you can't use reflection to get into the internals of a class, to access a class. Then we have reliable configuration. This replaces the Classpath mechanism with a means for program components to declare explicit dependencies upon one another. It is based on a capacity to declare dependencies between modules, and we can now know at compile time if a module is missing or if a dependency is not fulfilled. And dependencies are basically in Java 9 analyzed and enforced at both compile time and runtime. And this reliable configuration is achieved by the requires clause. We will see in the module declaration you have requires and exports clauses. And I will show you an example. So every module specifies what other module it requires. Then security, I already told you, the JDK internal APIs are hidden. You cannot access anymore. Just a few of them you can access for which you don't have replacements, like Sunmisk unsafe, but all the other are encapsulated and are not accessible. So these are mostly the Sun packages. And this is important to improve security, because this was the reason why we had a lot of security issues in Java before. And even if you use this set accessible method, you can't make a class accessible. Scalability and performance. I already talked about performance. You don't have to search the entire class path in order to find something you already know, and it's a great performance boost. And degree of scalability. The degree of scalability of Java platform is increased because you can create smaller and optimized deployments that help reduce the amount of memory needed on the corresponding running device. So, because these new custom runtime images contain only the module that you need. You don't need to install the entire JDK anymore. So, that's very good. Now let's see how the JDK, as I've told you, has been modularized. So now you have modules. It was divided into a set of modules, and if you want to find all the modules that you have, you can run Java list modules. There are now 92 modules. And the platform modules are the modules that are derived after the splitting of the JDK. These are platform modules. Then you can also create your own modules if you want. And there are two kinds of platform modules, standard modules and non-standard modules. Standard are the ones that start with Java and JavaX from these packages. And these contain standard API packages and non-standard API packages. And they also can depend upon non-standard modules. And the non-standard modules do not export standard API packages. And that's very important because the source code that depends only upon Java SE modules will depend only upon Java standard SE types. And this ensures portability across multiple implementations. Then here you can also put a module. You see this module Java naming. Java naming is a module, and you see everything that it exports, uses, provides, and contains. I will explain what this means. Basically, this is the module declaration. This is the module info.java file that you see here, except the contains clauses. The contains clauses are not included in the module declaration, so it exports. So that packages, Java's naming directory are exported, are made accessible to outside of the module, but are accessible if the other module reads Java naming, and the uses and provides clauses are used in context of services. I won't talk about services in this presentation. Then this is the new module graph that contains only the Java SE module. So this is how the JDK has been modularized. And at the bottom you have Java base. This is where you have Java lang string, Java util, everything you have in Java base. And you have two kinds. So with blue you see the modules. You have two kinds of lines. The solid ones are represents implied readability. For instance, Java SQL has an implied readability to Java XML. What does it mean? It means that if you need Java SQL, in Java SQL you use, let's say logging, okay? You use Java util logging, and if you require Java SQL, it also requires public Java logging, so you don't have to say, I need Java SQL and I also need Java logging, because you can also access the types in the Java logging. And then with dashed lines, you have the modules, you have simple readability. You have Java Compact 3, Java Compact 2, Java Compact 1. These are the compact SE profiles. And these are all aggregator modules. So they don't contain code. They just require other modules and export everything. And it's the same Java SE and Java SE. And you can see every module requires Java base. And this is implicitly. You don't have to write into module declaration, I require Java base. It will automatically require it for you. Java base had about 6,000 classes, and it's right at the bottom. So this graph you see has no cycles, has no circular dependencies, and it's a clean graph. Let me show you how the JDK source code has been changed. So the source code was also reorganized around modules, and even the build system has been changed in order to build modules. So as you see, you have source, and now you have the module name, and this is what's new, the module name, and then you have the 90 modules, Java .base, java.sql, and JDK . And inside you have code for specific operating systems, and then you have so it's like before, like in Java 8, but you have the Java you have the module name, and you see there the lib directory. This is present only in Java base, but and you have also the native directory. This holds C and C++ source files, native classes and procedures. Good. Let's. So this is the source code, and we see the new structure of the JDK and JRE. So this is the old structure that we have. We have a JRE. We have two bin directories, and you can see what has been splitted. And this is the new structure. So this is how a modular runtime image looks like. So when you build a modular runtime image, it has only three directories: bin, conf, and lib. And as you see there, tools.jar and rt.jar have been removed. And this has a great impact on frameworks, because a lot of frameworks use these jar files, and these frameworks have to be adapted in order to work with Java 9. The bin directory, the new bin directory, contains command line launchers defined by the modules linked into the image. And you have a conf directory. This contains property files, policy files, and other kinds of files, but everything that is in conf directory can be edited by the developers. And in JDK 8, this was not the case. There were files that could not have been modified. And you have the lib directory. This contains the runtime system's dynamically linked native libraries. Good. Let's see what kind of great. This is the encapsulation of the internal API. So as I've told you, the internal APIs have been encapsulated in Java 9. Which one? This one. So they made a classification. We have critical internal APIs, and they saw, okay, where are they used? Which is the rate? How they are used? And these ones that you see here, SunMISC, Unsafe, SunMISC, Signal, they are still accessible, but they are the only ones that are accessible. They were put in the module JDK unsupported, but everything else is now encapsulated from the internal JDK API, so they cannot be accessed. And this is the cause why much of the code and much of the applications will break when you switch to Java 9, because they can't access them, and you can't compile the application, you can't start it, you get an error right at the beginning. So the internal APIs are the ones in the Sun package, but not only. Now let's see. But there is a solution to break this encapsulation, because that would be a nightmare not being able to do this. The errors are a little bit in this direction, should be. So you have the new option add exports. And if I want to make sun.NET package in module Java base accessible, I can run add exports Java base, name of the module, package, and my module name. And then sun.NET will be accessible in my module. So this is a way to break encapsulation using the add exports command. Then we start defining modules. So Jigsaw modules is a fundamental new concept in Java 9. They are basically source files grouped as packages. So you have a module, contains packages, contains classes. And what they contain native source code, configuration files, resource files, and very important, the module info.java file, which is the module descriptor. This is the module declaration, and you will find it on the top level of the root directory. So right at the beginning, you have module info.java file, and then you have the packages according to the package structure. And this is the module declaration. So this is how you declare a module. Here I declare my module and module name. Every module has to have a name. And I can use 4 types of clauses: requires modules. That means, I will explain in the next slide, but provides and uses are used for services. I won't describe them today. So this is the content of module info.java file, and for each module there is one module info.java file. The requires, as you can see, my first module requires my second module. So in this case, my first module can access the types from my second modules that are exported. And my second module exports my first package. So my first package will be accessible in my first module because I read my second modules and my second module export these packages. And you also have a second kind of export. This is a qualified export where you specify exactly the modules where you want to export. So here I export my second package only to my third module and my second modules. So in this case, so if you try, let's say, to use, you have to write requires for every module. You can't use comma-separated modules. You can use asterisks. It won't compile. This is the only place where you can use comma separation using a qualified export. So this is how you create this. You create a definition of module declaration in Java 9. And by default, if you don't write anything, then your module does not require everything, then it cannot be accessed because by default you have strong encapsulation and you have to define which kind of packages you want to export. If you don't define something, then you can't access these packages. Then you have some types of modules. The weak modules have been introduced only in September 2016. Why? Because they saw that there are a lot of frameworks that can reflect over modules' internals. And the non-public elements couldn't be accessed with reflection. And that's why they introduced the weak module notion. This exports all of its packages, so you don't have to write the export clause. And so what kind of frameworks? I can think of Guava, I can think of JPA, and so on. But the standard modules, if you don't specify weak, you have strong modules. And these have requires clauses and exports clauses, as I told you before. You have to specify the export clauses, and you also have an exports private. So if you write exports private, you make the public types suitable for reflection, but only if you write exports private. Weak modules, the unnamed modules and automatic modules are exporting like using exports private. I will tell you lately what they mean because we have less time. Then we have automatic modules. What are automatic modules? For instance, you have a jar file and you want to transform it into a module in order to be able to use it. So you put it on the module path and it automatically becomes a module and has the same name as the jar file. And automatic modules, they export all of their packages and also read all the modules. And they can be used especially for third-party code. So it's basically, as I told you, a jar file that you take and put on the class path, and you have an automatic module. Very simple. Then you have observable modules. They represent all the modules from the system. They can be platform modules, library modules, and your own modules. We see what kind of accessibility changes have been done in Java 9. So in Java 9, when you have public, that doesn't mean that you can access it. 3 conditions have to be met. The type has to be public, the package has to be exported, and the module has to read the other module. Also, core reflection does not work, which is the reason for so much discussion and so many frameworks that break, because core reflection does not work by default. And simply setting a public modifier to a type does not mean that access is applied. So that's the biggest change in Java 9, which has a great impact on anything. Then we have implied readability. I've told you about implied readability. You can write requires transitive. I showed you in the example in the module graph. They changed the name. Previously it was called public, now it's transitive. So if you use Java SQL, and you see there Java SQL contains types from Java logging then if you require Java SQL, because it requires transitive Java logging, you don't have to also write requires Java SQL, requires Java logging. It's enough to write requires Java SQL. Then you have the new concept of modular jars. So these are jar files that additionally contain a module info.class file. So that's the only difference to normal jar files. They can comprise only one module, it's very important to remember, and can be used on the module path but also on the class path in order to provide backward compatibility. They are built with the jar tool, and this is the structure. So you have all the class files and you have also a module info.class generated. So they are called modular jar files. But if you place them on the class path, they act like a normal jar file. And so you can place them on 8 or 7 on the class path, and the module info.class file will be ignored. And if you place them on 9, then module info.java class will be used. Then you have the JMod files. These are not so important. They are similar to modular jars, but they can contain native code. So they have the extension JMod and should be used when modular jar files cannot be applied. For instance, because some JDK modules have native code. They are basically just used to build the JDK images. Let's see how you can package, because I told you you have the classes and you want to package them to create a modular jar. And you use the jar tool and you say jar create file, then you specify the jar file name that you want to create. And you also have to specify the main class, or using the main class option, and the output directory. And then you can use the -p module descriptor in order to list the content of the jar file. So here you have so this is the way that you can create a modular jar file. Let me show you the new module path. You have class path, and in JDK 9 you have the new module path. This is specified using the module path option, and the Java compiler uses module path or -p. Then the module path represents a sequence of directories that contain modules. So you can give a sequence of directories. Here are the modules I specify in my compiler, and it takes all the modules from there and compile them. And it can be mixed together with Classpath. So you can compile and say -p, list of directories, and then -cp, Classpath, and you also can specify the jar files. Let's see how you can compile. So when you compile, a resolution is invoked. You compile, and it builds the module graph and sees what kind of modules are needed, because you have transitive dependencies. And you can use, so you use Java C, you specify module path, the module path option, and then a list of directories. -d, you specify where should it output. This is a path to the module info.java file. And there is a difference between module path, where you find all the modules that are already compiled, and module source path, where you find them, the ones that are not compiled. But you can also here compile everything using find name.java, and you compile everything and put it in the output directory. After you have compiled, you want to run it. So you run using the module path option, and you say Java -p, list of module directories, -m, module name, and you also have to specify main class name if you don't use a modular jar. But if it finds a modular jar, then you don't have to also specify the main class name, because the main class name is already specified in the modular jar. So you say Java -p, list of module directories, and so you can run your application. Now you have the JLink tool. This is used to assemble a set of modules together with their dependencies into a custom runtime image. So this is how you use it. You can create a smaller and compact custom runtime image by specifying the module path and the add modules option so this here you specify which kind of modules do you want in your runtime image, but it will run that it will also search for all the modules it will depend. So your module has a dependency, you put it in module name, it will search for all its dependencies, and all the modules that are found will be put in the runtime image. And this is the way how you can have a runtime image smaller, and basically you don't need the entire JDK. You have the Jade App Store. This is important for, this is already in 8, but it has been enhanced in 9. When you switch to Java 9, you want to see, do I have JDK internal APIs? So this is a statistical analysis tool, and you say Jade Apps minus JDK internals, and here I use, for instance, Guava. And I want to see, does Guava use unsupported JDK APIs? And it finds that it uses SunMISC unsafe, and it basically for most of the JDK internal APIs, it suggests replacements. Here is not the case, but this is a very useful tool of how you can find dependencies on JDK internal APIs, so you can provide replacements for them when you switch to Java 9. Now, migration topic, this is a very complex topic. I will try to summarize it. Basically, when you have some jars, you can put them on the module path, and you have automatic modules. But there is also a way using the Jade Apps tool and the gen module info option. So it will generate a module info.java file for you automatically, because it will search what kind of dependencies there are. I don't think that I have time to explain everything, because this is a very complex subject, but it's possible. So there are 2 ways to migrate: top-down migration and bottom-up migration. Now let's see how you can prepare for Jigsaw. As I've told you, avoid JDK internal APIs in your code. Find a solution to replace them and use Jade Apps in order to find them. Then avoid having dependencies on rt.jar or tools.jar, because they were removed. Then there are 6 methods that have been removed. So if you use them in your code, then you should remove them. Then avoid using the old version string format in your code. This is not part of Jigsaw, but the string format has been changed in JDK 9. And if you use java.version, then your application will not work anymore. So try to do this change. And also check for split packages. Split packages are basically, they occur when multiple loaders define classes for the same package. So a loader cannot delegate to 2 different loaders for the same package. This is a complex subject. I won't be able to cover it here, but you should be aware of. And there are 6 modules that are not resolved by default, and here they are listed. And in order to avoid a no class def found error, you have to make the modules resolvable by using the option add module. So this is a module, you specify add module, module name, and it will search for all the transitive dependencies of that module. Then, as a conclusion, Project Jigsaw is one of the biggest changes in the Java platform since it was introduced back in '95. It is a very complex subject. I'm really sorry that I can't explain all the internals of it, but this is due to the lack of time. It addresses a couple of important existing problems in Java, and it changes the way we architect and design software applications using Java 9. And here you have some resources. So you have the JAPs, how they specify what has been done in Jigsaw. The JDK has been split it into modules, then the source code has been modified, then you have the modular runtime image, as I told you, where we removed tools.jar, rt.jar. We encapsulated most of the internal APIs. They are not more accessible. And we have the J-link, the Java linker, in order to link multiple modules to create a compact runtime image. Then that is basically a Java runtime image that you can use it instead of the entire Java runtime environment. You can also see the source code because there's a lot of work being done there. It's on Jigsaw Jake, and basically this is all regarding my presentation. So I think time is also okay.